So first step every time we solve an equation is remove the parentheses. So we're just going to use the distributive property right here. So we won't write down the original equation on our paper usually. You can if you like, but I would write down 6 subtract 2 times b is equal to b subtract 5. Then what's the next thing we look for? Okay, so look at that side. Any like terms? Look at that side. Any like terms? Okay, awesome. I love it when we don't have to do that. What's next? Okay, we don't want variable on both sides. So which one do you want to get rid of? The negative 2b? So you guys are over having the variable on the left now, aren't you? You really don't care about that anymore. So you're going to add 2 times b to both sides to get rid of that variable. And it's really important that you rewrite the equation at this point. Don't try to do 2 steps at once. Don't try to get rid of the variable from one side and get rid of a constant. Just do 1 step at a time, okay? So now what do you want to do? Okay, so we're going to add 5 to both sides. These cancel. So 11 equals 3 times b, and then we're going to divide both sides by 3. And honestly, we're kind of done right there, aren't we? That's it. Now we can write 1 times b now, if we like, equals 11 over 3, and that's fine. But we don't even have to write that part down. Oops, still can't see it. There we go. So this really isn't too much different than what we've been working on, is it? One more step. You okay with that, Gracie? Okay, and this is the last step. There are really no other steps to solving an equation. At least an equation with one variable, which is what we're mostly concerned with here. So here, get rid of the parentheses for me, please. Oops, plus 7. So just rewrite that equation without the parentheses. Okay, in a second I'm just going to call on one of you to have him tell me what to write. Okay, Wyatt, tell me what to write.
3 plus x plus 7 equals negative 4x plus negative, or minus negative 8. Minus 8.
Okay, subtract 8. Yeah. So Wyatt remembered to distribute the negative as well. So he took negative 4 times both those. That's awesome. Okay? All right. Nikai, what do I do next? Combine like terms. So I think we're going to put the 3 and the 7. We're just going to put them together, aren't we? So that's 10. So that's just a simpler way to write 3 plus 7. Okay, think about what you want to do next. Okay. Add, I don't see a 4.
Add 4x.
Oh, add 4x. I can do that. I can add 4x to both sides. This is where we really have a tendency to get mixed up. I have a lot of you guys want to get rid of the constant right at this point, but you have to get rid of the variable from one side. It will make your life so much better. So 10 plus 10x equals negative 8. Make sure we bring down that negative along with it, right? Now what?
Add 8.
Now I can add 8 to both sides. That would give me 18 plus 10x equals 0, wouldn't it? If we added 8 to both sides. Is that helpful though? Okay, so what do you want to do instead? Okay, so we want to subtract 10. That way we isolate the variable a little bit more. So that'd be 10x equals negative 18. Now what? Okay, so divide both sides by 10. And this is how I usually would show my work. I would cancel those out and say, okay, that's 1x now, right? 1x. And over here to the side, I would just put negative 9 over 5. I would reduce the fraction down. Now you can put it down below if you like to do it that way better. Doesn't really matter. That's how it works.
Did everything right except for 6 and 4. I thought I added up to 9.
Oh, see, and that's the thing. That's the thing that kills you on these. I don't think there's anything in this problem that's difficult, but there's like 20 different little things. If you miss a sign, if you add things together wrong or do a little subtraction thing wrong, you're done, right? Any little tiny thing. If you say 3 and 7 makes 9 or something, or 11, it's over. If you miss this negative 4 times 2 is negative 8, you're done. That's it. Doesn't matter what. You can do 19 things correct and 1 thing wrong, and it's wrong. So what does that tell you about going slow and being careful? Why do you think I want you to go slow and be careful and show all your work and everything, right? And also the reason I want you to show your work is so that when you're making a mistake, I can see it and tell you what you're doing wrong. If all I see is an answer, I can't help you, can I? Okay, all I can say is, well, it's wrong. That's all I really know. Okay? All right, I'm going to give you another one. Let's see how you can do. Now, I just want you to do the first step again because it's a little bit of a thing in this case. Can you just get rid of the parentheses? Okay, do we have are the parentheses gone? Can I talk about this now? So, do we have to use the distributive property here with just that negative in front? Do we have to distribute the negative? Absolutely. This says, it doesn't just say subtract 2x, it says subtract 2x and it says subtract 5. So you have to distribute the negative. Sometimes we like to think like there's a negative 1 there, if you like. So we're going negative 1 times 2x and negative 1 times 5. But it's going to change the sign of everything inside the parenthesis, not just the first term. What about this set of parentheses? What's it doing?
Adding?
Yeah, adding. Let's add x. And let's add negative 3. Do you guys want to put plus negative 3? What do you want to put?
Minus.
Okay, so what were those parentheses doing?
Scrolling.
Looking pretty? I think that's pretty much it. They were sitting there looking pretty. They really didn't affect anything, did they? And sometimes that's the way it is. They're not really necessary. Okay? What now? Thank you. Add like terms. 12 and 5, negative 5, sorry. 7. Subtract 2x. And then negative 2 and negative 3 is negative 5. Plus x. That's way better now. What do you want to do now? You want to add to 2x? I'm going to subtract x from both sides, just to bug you. So I get 7 subtract 3x equals negative 5. What happens if we forget to bring that negative down? Anything good? No. And then I'm going to subtract 7 from both sides. So I get negative 3x equals negative 12. Now you guys went ahead and solved this, and you all got 12 equals 3x, didn't you? Right? So you divided both sides by 3, and you got 4 is equal to x. I am going to divide both sides by negative 3, so that I get positive 1. And I still get x equals positive 4. So it doesn't really matter, does it? What do you think? You okay with this? Okay, now, does every single equation like this have one solution? One number makes it right, and that's it. Who says yes? Who says no?
I don't know.
Well, let's take a look. Sometimes we run into weird stuff, okay? You're solving an equation, and you add your like terms, and you end up with something like this. And you might not notice what's going on, but then when you try to eliminate the variable from one side, what happens?
0.
Yeah, that gives you 0x, and that gives you 0x, and you end up with 4 equals 4, a true statement. Okay? Now I want you to think about this original equation. What could x be? Could x be a 0? Would that make it true? It would be 0 plus 4 equals 4 plus... Could x be a 2?
Yeah.
3 times 2 plus 4 equals 4 plus 3 times... Does that work? Could x be a 10? Okay, could x be a negative 10? Can you give me a number that x could not be?
0. 4.
Okay, 3 times 4 is 12, plus 4 is 16. 4 plus 3 times 4 is 12, so 4 plus 12, that's 16. I? As in the square root of negative 1? 3 times the square root of negative 1 plus 4 equals 4 plus 3 times the square root of negative 1. X can be anything. In this case, we say it has infinitely many solutions. Okay? It doesn't matter what x is. Completely unhelpful, by the way. It's not what we want, not what we're looking for. It usually means that when we set up the equation to solve some real-life problem, that we didn't do it right, that we messed up somehow. Okay? So, if you get a true statement like that with no variables in it, what do you say? What do you say?
True. Infinite many
solutions.
Yeah, perfect. Infinitely many solutions. Now there's other problems. What if you end up with something like this? 3 plus 2y equals 2y plus 6.
Then that's not the same.
False.
Okay, it's a fault. When you subtract 2y from both sides, what do you get? You get 3 equals 6. You get a false statement. Right? So, if you get a false statement, what that means is...
No solution.
No, that's right, no solutions. Oops. It doesn't matter what number you put in for y, it's not going to work. Okay? So you need to understand when you have infinitely many solutions and when there's no solutions. Okay? So true statement, that means anything will work. False statement, that means nothing's going to work. Both of these are bad. Do you understand? These are not what we want. These are not what are we looking for when we solve a linear equation? How many solutions are we looking for? 1. Yeah, we're looking to solve the equation and come up with that one number that makes it true. Okay? And by the way, anytime you look at an equation with one variable, okay, if we talked about this before, if the variable's to the first power, then how many solutions will it probably have? It'll probably have one solution. Okay? If I have something like this, x squared equals 9, now how many solutions will it probably have? Guess how many?
Infinite.
2.
Oh.
It'll have 2. Yeah, that's a good guess though. Gage, that's not going to happen anymore.
Okay, sorry.
Period. Never again. That will never happen.
Okay.
This is going to have probably two solutions. I can actually tell them both to you. Positive 3 and negative 3 will both make that statement true. See, because 3 squared is 9 and negative 3 squared is 9. They both work. Okay? If I have an equation that looks like this, x cubed plus 4x squared plus 8x plus 9 equals 0, guess how many solutions it's probably going to have? Probably going to have 3. All right? Well, if you look at the highest exponent going on, okay, so in this case, the highest exponent here, the highest exponent, right? And I know you don't think this, but this is x to the 0. We don't ever write it. What is x to the 0, guys? And what's 1 times 6?
6.
Still 6. We don't need to write that there, but it's there. Okay. So you look at the highest exponent going on, and that tells you how many solutions. So we know that this is going to be a single solution, most probably. It's possible it'll have no solutions. It's possible it'll have infinitely many, but in general, we're going to just end up with that one solution. All right, last one. Let's see if you can get rid of the parentheses here. And I'll just call on you guys to help me here in a minute. So just do one step, please. Just get rid of the parentheses. Okay. Did you write down the original equation?
No.
Good. Takes forever. All right. So what's the opposite of 4y?
Negative 4y.
Okay. What's the opposite of negative 17?
Positive 17.
Okay, so we're all going to use the distributive property there. What about here?
That just minus 5.
Okay. It's a good thing Matthew's smart. The rest of you, what's the matter with you? Come on. What's the point of this set of parentheses? They're not doing anything. Okay, subtract 1. And then what's the opposite of negative y?
Positive y.
Positive y. Okay. Doesn't that look better already? Doesn't it look simpler?
Yeah, it looks
Right?
like
Simpler. Okay, now what can we do?
Combine like terms.
Okay, combine like terms. Do it. I think most of you have done it already, haven't you? Okay. Kylie, what'd you get?
Negative 5y plus 17 equals 3y minus 9.
Okay. Mason, what do you want to do now? You want to get rid of a variable or get rid of a constant? What do you want to do? Which one?
5. The negative 5.
So you want to get rid of that one? So if we add 5y to both sides, you want to get rid of this one right here. So 8y subtract 1. What now, Jim?
I say add 1.
Okay, so you added the 1 to both sides. So that's 18 equals 8y.
Yeah. Let me keep going.
No, I'm looking around for the person who looks the scaredest. Thomas, what now?
Divide it 8.
Say divide both sides by 8. Yeah, that's it. You guys, you always want to say divide by 8 or divide 8 or something. I always want to hear both sides. That's the words that I want to come out of your mouth, is the both sides part, so that we're keeping the equation equal. So 8 equals, and I would just reduce the 18 over 8 down. 9 over 4? So I would just kind of do that. What do you think? Good?
Yes.
Good? Now you did this last year, right? It's not really new, but it's something we really need to take some time and practice on. And so I made an Alex assignment today for you because I like it, because when you do the equation and put down the wrong answer, it immediately says, nope, try that again. So
Then you try again and
let's do that right now. Alex 28, there's only 15 problems.
I think
Hey, Gage, scoot to your right just a little bit. Oh, no, keep